In this video tutorial, I'll be showing you guys how to use Autodesk's Ecotect analysis program, in which we'll be using the program to analyze sun and solar amenity and its relationship to buildings. So the particular building that we'll be analyzing in this tutorial is basically this building right here that me and my group just recently submitted for a project in University of Melbourne, run by Dr. Marcus White. Basically, what we are going to use into Ecotect is just a simplified massive model of this particular model right here, which was created in Rhino. So even though the details are much less, I think the information will be enough in order for us to get a picture of how the building is in relation to solar amenity and solar orientation. So yeah, it will be good enough for it. So what I'm going to do now is export this file from Rhino as a 3ds file and import that into Ecotect. So I'm going to go to File, Export Selected, and I'm just going to select it. And I'm going to just export it here as Massing Sun Analysis. And I'm just going to overwrite that. I'm then going to open Autodesk's Ecotect analysis. Then I'm going to import the file into it. So I'm just going to go import 3D CAD geometry. The file type is already a 3D Studio file, which we did earlier because that's the compatible file. So we're just going to go to choose file, select it right here, and then you could see that Autodesk's Ecotect is reading it, so that's good. And we're just going to continue on with open is new. So you can see here that the massing model is now in the program. So what we're first going to do is just display some shadows, so we can get an understanding of the sun. But most importantly, what we have to do first is locate this massing model in terms of its location in the world. So what we're going to do is if we click on this button right here, set current time and or location, then we're going to go to load weather file, and now we're just going to select it, which is Australia, Melbourne, because that's where I'm making this tutorial for you guys. And then we'll just say yes to update global position to match climate file. So then now that we've done that, we can put on the daily sun path over here under shadow display, and now it's gonna show us the sun path on a daily basis. I mean a daily sun path, and how our building relates to it. So we could pan around, and this sun path is responding to the actual location in which we've placed it as Melbourne. We can also track the sun path by putting the annual sun path over here, which gives us even more greater detail of information. So it's really handy, so we can get an understanding of the different sun paths and the different types of shadows that are cast upon our building, and most importantly, which areas are exposed to the most sunlight. We can also use the time over here to see all the different types of times of the year and the different types of shadow castings that it does. Now the next thing that I'm going to show you guys is how to run a basic calculation of seeing how much solar energy is actually absorbed by the building right here. So what we're going to do is, if we just click calculate, and then once you scroll down to solar axis analysis, and then we'll just keep clicking next. So incident solar radiation, yes. For specified period, yep. And we'll continue on. Next. Yep. Objects in model. These existing shading tables, yep. And we'll just hit OK. So now that the solar axis analysis program has just completed running, now it has shown us the areas that absorb the most solar energy. So this is basically the color diagram, and gives us a pretty good indication of which areas get hit the most, which would be the top in this sense. And so now another analysis that we can run is running the weather tool, and then what that can give us is it pretty much calculates the best orientation for the building in relation to the sun, solar amenity, and the solar axis. So we just hit this run the weather tool. And then over here, the location data should match up with what we had earlier, which it does. So we've got Melbourne, Victoria, Australia right here. Then we just go down to solar position, and then we just click best orientation. Then we click OK. And now the weather tool is gonna calculate for us. And it's basically saying that the best solar, I guess, orientation is exactly 0 degrees north, in which the building is already facing at the moment. So that's the area that gets the best solar access, really. And that's basically how you can begin to use Autodesk to generate some interesting some solar information about your projects, and I hope it's been useful, and we'll catch you soon. Thank you.